Hello and welcome back to the Networking Fundamentals section of this course, where we're discussing the foundations of Ethernet and Internet Protocol. In this video, we'll be covering Layer 2 concepts, and specifically switching principles. Recall our OSI model, where at Layer 2 we have MAC addresses, that is, media access control addresses for our addressing, and our protocol data unit at Layer 2 is the frame. So let's take a look at these MAC addresses. As I just mentioned, the Layer 2 address is called a Media Access Control, or MAC address. If you are ever discussing Layer 2 addresses with your colleagues, you will almost certainly reference them as MAC addresses, or Layer 2 addresses. It's very likely, if you were to reference it as a Media Access Control address, that your colleagues might not know what you're talking about. MAC addresses must be unique within a broadcast domain. When sending a broadcast, the MAC address is what identifies every device on our broadcast domain. And because of that, if we have duplicates, you'll run into problems where we don't know which device is actually talking and might run into issues with trying to switch our frames and get them to the appropriate destination. As I just mentioned, the Layer 2 protocol data unit is the frame. And MAC addresses are 48 bits long. This is written as 12 hexadecimal characters. You may or may not be familiar with hexadecimal. This includes all numbers from 0 through 9 and all letters from A through F. This makes up 16 possible characters, each character representing 4 bits. And with 12 hexadecimal characters, we get 48-bit long address. This is often referenced or written as 2 hexadecimal characters and then a colon, and then 2 more, and then a colon. Sometimes you will also see them written as 4 hexadecimal characters, separated by periods. The broadcast MAC address, one that indicates that all nodes which receive this frame should process it, that I am broadcasting some information out to all nodes that receive this. The broadcast MAC address is all Fs. There is only one broadcast MAC address, and this is it. MAC addresses also have unicast, meaning 1-to-1, a single node speaking to one other single node, as well as multicast addresses, one single node speaking to many or multiple other nodes. And the multicast MAC address range is here. You probably don't need to be familiar with the multicast MAC address range for the exam. However, you should certainly know that multicast MAC addresses do exist. And it is very important to know, not only for the exam, but also for your day-to-day work, what the broadcast MAC address is. So now that we're familiar with how Layer 2 addressing is written and how large our address field is at Layer 2, let's take a look at what the rest of our Layer 2 header looks like. So at Layer 2, both our source MAC address, so the address of the source node that is generating or transmitting this message, both the source and the destination address are included. Here we have a diagram showing our Layer 2 header. We have some preamble information here, but primarily what I want to take a look at is the destination and the source MAC address. We also have the ether type, which tells us what type of payload that we have here, what type of frame that we have here. Layer 2 switches and Layer 3 switches use the source MAC address in the frame to build the CAM table. Recall our switch. And if we have multiple computers connected to our switch, okay, and let's say this is computer A, B, and C. If computer A is sending out a frame, it has a source of MAC A. We're just going to say it's all A's. And a destination, let's say it's just sending a broadcast. So it's all F's, right? So workstation A is on port 1, workstation B is on port 2, workstation C is on port 3. The switch, when it receives that frame, it will look at the source MAC address first and see that it is all A's. It will now write in its CAM table that we have all A's living on port 1. So we've got port and MAC. Now let's say B and C both receive that broadcast and they both respond to workstation A, where B has a source of all B's MAC address and C has a source of all C's. And let's say, since they are responding directly to workstation A, that they have a destination of all A's. When the switch receives this response, it will look at the source MAC addresses first, and it will update its CAM table, saying that B lives on port 2 and C lives on port 3. It will now look at the destination MAC address and see that it is all A's. It already has an entry in its CAM table showing that all A's lives on port 1, so it will forward those frames out port 1 towards workstation A. When a switch receives a frame that is either to the broadcast address of all F's or is to an address which it does not have in its CAM table, it will flood that frame, sending it out all ports in the same broadcast domain except for the one it came in on. So I hope that adds some more context to how a switch forwards frames now that we have some more information and are able to talk more about the layer 2 addressing. So switches do not hold on to these CAM table entries forever. They do age out at some point. So as we've mentioned before, a switch's main purpose is to learn what port each MAC address lives on. A switch looks at the source MAC address of incoming frames and saves that information to the CAM table as we just mentioned, where we have MAC addresses in one column and the port on another column, and we're trying to learn which MAC address lives on which port. The entries in the CAM table will age out eventually when they're idle for a period of time. So we actually have another column here. It's the age column. So by default, a lot of switches have a 5-minute age out timer, or 300 seconds. After 300 seconds of not seeing any traffic come in for this MAC address on this port, it will erase this entry from the table. Then any frames that come in with a destination MAC of all A's of that entry, it now no longer knows where that's located. So PC1, let's say it has a MAC address of all 1s, PC2, all 2s, PC3, all 3s, PC4, all 4s. Let's say PC1 sends out a broadcast. We now know that PC1 lives on port 1, PC2 receives that and responds. Same with 3 and 4. So we know that 2, 3, and 4 live off of ports 2, 3, and 4, and they have all just been seen right now, so the age is 0 seconds for all of them. Now let's say 5 minutes go by and PC 1 and 3 have been really chatty. So their age is still 0 and 0. But PC4 hasn't been heard from for the last 299 seconds, and nor has PC2 for the last 299 seconds. At this point, 1 more second, and PC4 will be erased from the cam table as well as PC2. So when PC1 sends a message with the destination of all 3s, then the switch will just forward that out to PC3. However, when it sends one with a destination of all 2s, the switch no longer knows where that is located. So it will proceed to flood out that message to all of the other ports in the same broadcast domain to make sure that PC2 receives that message. Once PC2 responds, then the switch will now know, once again, that PC2 lives on port 2 and will proceed to have an age of 0 seconds. Now, I've mentioned flooding and forwarding a little bit, that to forward a frame, the switch inspects the destination MAC address. So it's trying to build its cam table so that it can forward frames appropriately. If an entry exists in the cam table, it forwards that frame out that port. However, if it does not exist, or the destination is a broadcast, then the frame is flooded out all ports in the same broadcast domain, except for the port that it came in on. This traffic of flooding is done for BUM traffic. That is broadcast, unknown unicast, and multicast. This traffic is flooded to ensure delivery to all interested nodes. An unknown unicast is a unicast frame which does not have a destination MAC address in the cam table, so it floods out that unicast. And multicast is flooded unless we're running IGMP snooping, so that the switch is aware of what devices actually care about this particular multicast stream. But IGMP snooping is definitely outside the scope of this particular course. It's just important to know that broadcast, unknown unicast, and multicast BUM traffic is generally flooded by a switch. I appreciate you going through this with me. I hope that this has been informative for you, and I would like to thank you for viewing.